So the same concept of thermal equilibrium is used in Zeroth law. So what does Zeroth law says? Let's take an example. Let's say we have a body named as A. There is another body. Let's name this body C. Okay, and we have a third body. For reference, let's give this name B. So we have three bodies A, B, and C. Now, as per Zeroth law, if I say that body A and body B, let's say the temperature of body A is T1, temperature of body B is T2. Even better, let's name this TA and TB, which represents temperature of the body A and B respectively, right? And similarly, let's say the temperature of body C is TC. So as per Zeroth law, if we say that temperature of body A is equal to temperature of body B, that is, if TA is equal to TB, first. Second, if temperature of the third body, that is C, is equal to temperature of the second body, that is TB. So we have two conditions so far. Let's say the temperature of A and B is same, temperature of B and C is same. Now as per Zeroth law, if we have this condition, we can say that temperature of A and temperature of C will also be equal. This is Zeroth law, which means if two bodies are in thermal equilibrium, other two bodies are in thermal equilibrium, then we can say that the first and the third body are also at thermal equilibrium, which is quite logical, right? अगर दो बॉडी का टेम्परेचर सेम है, A और B का टेम्परेचर सेम है, B और C का टेम्परेचर सेम है, तो ऑब्वियसली A और C का टेम्परेचर भी सेम होगा, और अगर नहीं होगा तो ये पॉइंट अटेंड करने तक वो उनके बीच में हीट एक्सचेंज होते रहेगा. तो पहले Zeroth लॉ का स्टेटमेंट देखते हैं, फिर इसका एक एग्जांपल है जिससे आपको और क्लियरली समझना है. सो नाउ लेट्स अंडरस्टैंड Zeroth लॉ. So what does Zeroth law says? If two systems are each in thermal equilibrium with the third system, they are also in thermal equilibrium with each other. The same thing we should discussed earlier. If two systems are each in thermal equilibrium with the third system, they are also in thermal equilibrium with each other. That is, if A and C are in thermal equilibrium with B, both are in thermal equilibrium with B, A is equal to B, C is equal to B, both same temperature. This also means that A and C will also be at same temperature, that is, they will be at thermal equilibrium. Let's take an example to understand this even better. So rather than taking some random bodies, let me take a practical example. Let's say on a table we have two different cups. Both having coffee. Okay. But the difference is one coffee is hot coffee while the other coffee is cold coffee. Right? Same content, same amount of volume, everything same. The only difference is the temperature factor, the amount of thermal energy that both the coffee possess. So let's say, as we studied earlier, let's say the temperature of this cup is around 30 degrees Celsius, while temperature of the cold one is 10 degrees Celsius. Okay. Both are placed in same surrounding. Let's say the temperature of surrounding is 20 degrees Celsius. Now what will we observe here? So as per thermal equilibrium, we know that until and unless thermal equilibrium is achieved, the exchange in heat energy will take place, right? So for this case, how will this exchange take place? Since this is comparatively at higher temperature than the surrounding in which it is placed, so this will lead to transfer of heat energy to the surrounding, which means this will lose energy, thermal energy, right? At the same time, my other body is at lower temperature than the surrounding, which means this will be continuously gaining heat energy from the surrounding. So this exchange will continuously take place until the cold coffee reaches at 20 degrees Celsius, which is temperature of the surrounding. As I told you earlier, surrounding is very large कंपेरेटिवली टू दिस कप्स, विच मीन्स यहाँ से अगर हीट चला भी गया है इसके पास तो इसके टेम्परेचर में कुछ खास फर्क नहीं पड़ेगा, इट वॉन्ट बी सिग्निफिकेंट इनफ। सिमिलरली यहाँ से यहाँ पे हीट जा रहा है तो भी इसका टेम्परेचर कुछ खास बढ़ने नहीं वाला। सो इसका टेम्परेचर हो जाएगा 20 डिग्री सेल्सियस बाई गेनिंग हीट, सो दिस विल बी गेन एंड देयर विल बी लॉस फॉर दिस वन, विच मीन्स इसका टेम्परेचर भी चेंज होगा। नाउ लेट्स से द न्यू टेम्परेचर इज 20 डिग्री सेल्सियस। एट दिस पॉइंट we can say that cup of coffee, let's name this A and the other one B. We can say that A, which is this body, is in thermal equilibrium with the surrounding. Similarly, the other body, which is this one, it is also in thermal equilibrium with the surrounding. So we can say that A is in thermal equilibrium with surrounding, B is in thermal equilibrium with the surrounding. This means that A and B will also be in thermal equilibrium with each other when the temperature reaches 20 degrees Celsius. We can clearly see all three are having 20 degrees Celsius temperature, which means all three are in thermal equilibrium with each other. This is Zeroth law.